Structure of the TT diagram. A TT diagram plots temperature on a y-axis. I mean, just we are going in the detail how TT diagram is being basically drawn and what is the significant and what is the understanding, from TT diagram, the diagram that I have shown above. Okay, so temperature is plotted on the y-axis against the time, which is on the x-axis, x-axis usually on the logarithmic scale. So you can see that we can go with the normal axis, means 1, 2, 3, 4, 5, 6, but logarithmic axis means we have, just converted or iterated to the logarithmic scale. Means 10 would be written as 1, okay, 100 would be written as 2, and 1000 would be written as 3, because log to the power 10, sorry, log 100 base 10 means log 10 upon, sorry, 10 base 10 square. Square will come in, in the prefix, and 10 log 10 base 10 is equal to 1. That's why we are having 2. Okay, I know that you are aware about the basic log rules. Okay, so here it is not just a normal scale, but here we are taking a logarithmic scale. Okay, so on y-axis we are having the temperature values, and on the x-axis we are having the time values. So it is taken as a logarithmic scale. That's why we must have to ensure, if we are going to conclude the final value of the temperature, then we must have to take the anti-log. Okay, so that we can have a real values. Okay, if we are just taking the data from the TT diagram. Okay, in the same manner, if we are taking the time values from the TT diagram, we must have to provide the anti-log of that value so that we can have a real values of time. Okay, the austenite stability region. At the high temperature, austenite is stable and does not transform. So at a high temperature, as you can see here, the austenite will be stable. Yes, you can see, right? At a high temperature. Okay. So austenite stability region is at the high temperature. Austenite is stable and does not transform. If we talk about the Pearlite transformation region, at the intermediate temperature. So at intermediate temperature, austenite transforms into Pearlite. The transformation starts after an incubation period and progress over the time. Okay, so in intermediate temperature, and due to the over the time, it gets, okay, so it gets converted into, or you can say the phase transformation occurs into the Pearlite. Okay, third one is the Bainite transformation region. Okay, so at low temperatures, austenite transforms into Bainite. The transformation also starts after a incubation period. It means you have a, at a very high temperature, you are having austenite. If you are keeping it at a high temperature, the austenite will be, in their stable condition. But as soon as you just start decreasing the temperature, I mean, you have a different process, right? If you are just in case you have taken a furnace cooling, right? Or you can say annealing. In the annealing process, you must be providing a sufficient time, okay, and you are decreasing the temperature slowly. So for that, after, at a high temperature, austenite is stable, but intermediate temperature, suppose it was at a 1400 degrees C, right? Then now at around 700 degrees C, they are converted into what? Into Pearlite. Okay, here we are, Pearlite. And okay, when it is just reaching very below temperature, or you can say at a low temperature, then the austenite is converting into what? Into Bainite. Okay, and now the austenite start and finish, sorry, martensite. So I mean, very below temperature, or you can say the below the critical temperature, the ms is what? The martensite start point, and mf means the final, the martensite final, where the martensite I mean, all austenite convert into the martensite, that is known as mf. The austenite begins to transform into the martensite, and the transformation is a time independent and depends only on the temperatures. Here you can see it is a time independent, only depends on the temperatures. Okay, so ms indicates the transformation of austenite into the martensite. Okay, and mf indicates the martensite. Okay, sorry, austenite, which is getting converted totally into a martensite. Here you can see in the diagram. Yeah, this one is. So you can see that the time is not required here. Time is independent. It's just about a temperature, right? Here, if you have decreased the temperature and you come here, then it is converted into the total Martensite. Okay, so MF is just indicating Martensite and MS is indicating Martensite start temperatures.